Hey guys, Mr. Betts here. When we are dealing with sequences and series, we're going to have factorials popping up quite a bit. And the reasons for that aren't obvious now, but they're going to have to do with later when we start taking derivatives and integrals with power series, with infinite polynomials. But what you need to know right now is they're going to be something that we're going to have to deal with. So first of all, just quick definition of what n factorial means, or any number factorial. So n factorial is just what we get when we multiply n times n minus 1 times n minus 2. So I'm going to use a specific example first. So 5 factorial is 5 times 4 times 3 times 2 times 1. So we can generalize that with n factorial as n times n minus 1 times n minus 2. Let's try that again. And that just keeps going all the way down to 3 times 2 times 1. So whatever n is, we just multiply n times all the natural numbers below it together. So that's pretty straightforward. But then we're going to start seeing expressions with n factorial or factorials in them. So if we want to simplify some expression that has a factorial in it, we have to know kind of how they interact with each other. So n factorial we know is n times n minus 1 times n minus 2 and so on. But n plus 1 factorial would be n plus 1 times n minus 1 times n minus 2 and so on. And you'll notice here that the top and the bottom have almost all the same factors. So starting at n, they're all the same. So the n's cancel with each other, the n minus 1's cancel with each other, the n minus 2's cancel with each other, and so on. So another way of dealing with this without writing all that out is to understand that any factorial is the same thing as that number times the number below it factorial. So for example, n factorial is the same thing as n times n minus 1 factorial. Okay, or to use a specific example again, 5 factorial is the same thing as 5 times 4 factorial. Now, neither of these is very useful here, but what is useful is that n plus 1 factorial is the same thing as n plus 1 times n factorial. And so by writing it like that, it's a lot simpler to see the n factorials cancel, and this is just going to be equal to n plus 1. Being able to simplify expressions that have factorials in numerators and denominators is going to make things a lot easier for us. So I want to also refresh relative rates of growth. So we've talked about with limits, essentially what I call dominance, what's going to dominate the numerator or denominator of a fraction in a limit. So if you remember the slowest, so I'm gonna write types of functions from slowest to fastest growing. So the slowest of the types of functions that we've talked about so far are the logarithms. Then the next is polynomials, and it's important for me to note here too that within each of these categories, we could have something dominating over something else. So for example, with a polynomial, x squared is going to dominate over x. So bigger degrees are going to dominate over smaller degrees. Then we're going to have exponential functions. And then factorials are going to be the fastest growing. And if you want to know why, I have another video posted that you can go back and watch when I initially talked about relative rates of growth. But we can use these ideas to answer questions about limits that involve all 4 types of these functions.